Alright, today's lesson is lesson number 80. We're going to be talking about graphing parabolas. So we started in class with this exploration, looking at the standard form equation and moving the sliders. So what did A do? Why was A significant?
It goes down.
It goes down or up, right? It changes if it goes down or up. Anything else? When you move A, what else did you see happening? The width of it, it gets wider and more narrow. Did anybody notice what values make it face up versus facing down? Yeah, go ahead. Positive and negative. Yeah, if it's positive, it's up. If it's negative, it's facing down. Okay, and then what kind of numbers make it kind of skinnier? What kind of numbers make it narrow? Farther away from zero or close to zero? Farther away, what does that do? Makes it smaller? Okay, and then what about making it wider? What kind of numbers make it wider? Closer to zero. Good, okay. And then what about H comma K, or H and K, why are they significant? How are H and K significant? H moves it to the left and right, okay. K moves it up and down. Can you find the point H comma K on your graph? Look for the point H comma K. Remember when we did like circles or ellipses and hyperbolas, the H comma K was like the center, so it was a significant point. Look for this point. Just stop moving the sliders and look for the point H comma K. Can you describe what that point is on your graph? Anybody? So this one has H as 1 and K as 1. If I look on the graph, the point 1 comma 1 is right at the bottom of this U. Do you guys see that? Yeah. Okay, so it's the vertex. So it's the very top of the U or the very bottom of the U. It's kind of like the center, but since we don't have a full like circle or something like that, we don't really call it the center. It's just the vertex, okay? So the steps are on the board as well. So first thing you want to do, I know these numbers are wrong. It should say 1, 2, 3, 4, 5, obviously. But first thing you want to do is make sure that your equation is in this standard form. And then when it is, you can pull out the important information. So H comma K is the vertex. And just like for an ellipse or a hyperbola, girls, you take the opposite of the one. When it's in parentheses like this, you take the opposite of it. So this would be, if it was x minus 1, it would be just 1 that you take for H. And then K is just whatever's on the outside. Okay? And then A, you want to identify what A is. And as we said, if it's positive, it's going to open up. If it's negative, it'll open down. And if it's a bigger number, it'll be more narrow. If it's a smaller number, it'll be wider. Okay, then you're going to make a table. We're going to talk about solving these with a shortcut method today. And then we'll plot and graph. Okay, so moving on to 1 and 2, just watch up here. Put your pencils down. Okay, watch up here. So number 1, the first thing I'm going to do is identify the vertex and A. So the vertex here, I take the opposite of what's with x. So it's going to be 3 comma negative 6. For my vertex. Okay, and then A is the number outside of the parentheses. So here it's just a 1. Okay? Now I'm going to do the shortcut. So everyone's paying attention so that they know what I mean when I say do the shortcut. Okay? I'm going to make a table. Oh, I plotted the vertex here also. This is 3, negative 6. Okay, now I'm going to make a table. It looks like this. X and then AX squared. That's all I need to look at. My A is 1, so this is just like 1x squared. Okay, now I'm going to go to the left and right of the vertex. So I'm going to look what happens if I go left or right 1 unit, and what happens if I go left or right 2 units. Okay, and then I'm just plugging in 1 and then 2 for x in this ax squared. Okay, A here again is 1, so this is like 1x squared. That will change, though, if you have a different value for A. Okay, so if A is 3, then you would do 3x squared and plug it in there. Okay, so plugging in 1 squared is 1, times 1 is just 1. Plugging in 2, 2 squared is 4 times 1 is 4. Okay, and now I'm going to use these as directions. Okay, so these are from the vertex. I plot these points. So from the vertex, I go left or right 1 unit, and I go up 1 because it's a positive 1. Okay, so if I go left or right 1 unit from the vertex, I go up 1. So those are my next 2 points that I plot. So I went left 1, up 1, right 1, up 1. Okay? Now I'm going to go left or right 2 from the vertex. Okay, so from the vertex, if I go left or right 2 units, I go up 4. Okay, so my next 2 points are here. I went 1, 2, 1, 2, 3, 4. 1, 2, 1, 2, 3, 4. Okay, and then I sketch the graph. And that's it for number 1. Okay? Keep watching up here for number 2. Okay, number 2, the vertex, I take the opposite of what's with the x, so it's going to be 2, comma, and then I just leave the k how it is on the outside. So 2, comma, negative 1. My a is what's in front of the parentheses, so a equals negative 2 here. And then I make my little table, a, whoa, spoiler alert, ax and ax squared. A is just negative 2, so this is negative 2x squared. Okay, and then my x's are just like directions. So I'm going to look at what happens if I go left or right 1 unit. What happens if I go left or right 2 units. Okay, plugging in 1 here. 1 squared is 1 times negative 2 is negative 2. Plugging in 2. 2 squared is 4 times negative 2 is negative 8. Okay, and then I use these as directions. So first I plot the vertex. The vertex is here at 2, negative 1. Then if I go left or right 1, I go down 2. Okay, so my next 2 points are right here. Then if I go left or right 2 units, I go down 8. So my next points are actually kind of off the graph. They are down here. You can't really see. But if you go over 2, then I go down 1, 2, 3, 4, 5, 6, 7, 8. So it'd be at negative 9. And then over 2, down 8 here. Okay, and then I just connect the dots to sketch my curve. It's kind of blocking this, but so there's 1 and 2. Okay, any immediate questions on 1 or 2? Do we feel like we could do this successfully? Not quite yet. Not at all. Okay, I'm going to back this up. I want you to talk to your partners. So 1s, walk them through number 1. And then 2s, walk them through number 2. Talking to your partner, and go. Okay, moving on. Here are 3 and 4. So number 3, guys, look at number 3. Talk to your partner and tell your partner what the vertex is and what A is for number 3. Yes. If you owe me time after class. As much time as you're gone. Okay. All right, so the vertex, what's the vertex here? Is it positive 1 or negative 1? Negative 1, yeah. You take the opposite of what's in the parentheses. Okay, so negative 1, comma, what's the y coordinate? 4. Good. Okay, and then A equals what? 1. Good. Okay, so I want you guys to make the little table for the shortcut. And I even got it started for you. And then plot the vertex and the other 4 points. Here's more of a start if you're, whoa, not that much.
I definitely can't do it. I know everything.
All right, there we go. So continue from here, finish, and graph number 3. All right, so if I go left or right 1, plugging in 1, I just get 1. Plugging in 2, 2 squared is 4. 4 times 1 is 4. So from the vertex is negative 1, 4 up there. If I go left or right 1, I go up 1. If I go left or right 2, I go up 4. And then I sketch the curve. Okay, talk to your partner and tell them if you made a mistake. See if you can figure out how to do it correctly. And then go ahead and start on number 4. Okay, guys, for number 4, what should my vertex be?
Negative 3, 1.
Negative 3, 1. Good. What's A?
A is 1. Negative 1.
A is negative 1. Good. Okay, and then you make your table. And then ax squared is really going to be negative x squared. Okay, finish the table values and graph. Okay, checking your work for number 4. So if I plug in 1 down here, plugging in 1 squared is 1 times negative 1 makes it negative 1. Plugging in 2 squared is 4 times negative 1 is negative 4. And then these are the directions that I use. So first I plot the vertex at negative 3, 1. Then if I go left or right 1, I go down 1. You guys are checking your work?
Yeah.
If I go left or right 1, I go down 1. So I'm here and here. Okay, and then if I go left or right 2, I go down 4. So left 2, down 4. And right 2, down 4. Okay, and then I sketch the curve using those dots.
That's a great parabolas.
Yeah, that's not great. Okay, and then here are the last 2 examples. So for number 5, the vertex is going to be 3, 1. Sorry, that should actually be 3, 0 because this is like plus 0 on the outside. So 3, 0, and then A is going to be negative 2. Okay, so the vertex is here at 3, 0. Then I'm going to make my chart. And I have ax squared, which is just going to be negative 2x squared for this. Plugging in 1, I get negative 2. Plugging in 2, I get negative 8. So then I'll go ahead and plot these points. So if I go left or right 1, I went down 2. And if I went left or right 2, I went down 8. And then I drew the curve. Okay, and then number 4, my vertex here, this here is just like saying x minus 0 squared, so my vertex is going to be 0, 2, and A will be negative 1/4. I make my table with negative 1/4 as A. Plugging in 1, I get negative 1/4. And plugging in 2 squared is 4, so 4 times negative 1/4 is negative 1. And then I plot these points. So my vertex is here at 0, 2. If I go left or right 1, I just go down a little bit. I'm just going down 1/4. Okay, and then if I go left or right 2, I go down 1 unit. Okay, so this is a wider parabola. Alright, so go ahead and work on the homework problems for these, and I will see you tomorrow. Thank you.